All right, second page. Notice what the function says. Instead of just having x, what do I have? Absolute value. Definition again is what? Distance away from 0. Excellent. So let's pick some points. Let's start with 0, 1, and 2. So the absolute value of 0 minus 2. Well, that's 0 minus 2, which is what? Negative 2. The absolute value of 1 minus 2. That's 1 minus 2, which is negative 1. And the absolute value of 2 minus 2, that's 0. So our points so far are 0, negative 2, 1, negative 1, and 2, comma 0. Let's plot those 3 points just to start. 0, negative 2, 1, negative 1, and 2, 0. When does an absolute value impact a problem? When what kind of number is inside it? A negative. So let's choose an easy negative to plug in. What can we choose? Yeah, negative 1. Let's plug in negative 1. So the absolute value of negative 1 minus 2. Well, think with me. What's the absolute value of negative 1? 1. 1 minus 2? Negative 1. So that's the point, negative 1, negative 1. Let's get some more points. Another easy negative number to plug in. Negative 2. So the absolute value of negative 2 minus 2. The absolute value of negative 2 is how much? 2. 2 minus 2 is 0. So we have the point negative 2, 0. Let's plot those points. Negative 1, 1. Negative 2, 0. Do you see a pattern? The blue dots from the positive numbers are going which way? Up to the right. The red ones are going which way? Up to the left. And so what you're going to do here is you're going to draw your answer, and it's going to look like a V. And the V is going to have an absolutely perfect 90-degree angle at the bottom. So this is the graph of a classic absolute value. Anytime you have an absolute value, what does the word value start with? V. So an absolute value is in the shape of a V. Put a little note out to the side there. Absolute value graphs are in a V shape. That will always be true. Now, the V might move around a little bit, Carson, depending on what the pluses and minuses are and if they're inside or outside. But the trick to an absolute value is to graph enough points so you can see where the V starts and then just make your V. So once you see the check mark in your graph, so plot a point, graph it, do a point, graph it, do a point, graph it. Once you see the check mark, then you can go from there and graph it. So the trick will be is to find this base, this vertex, see where it makes the turn, get 2 points on either side, and then graph it from there. You may only need 5 points, you may need 6 or 7, depending on the point. But don't just assume the V is always up and down on this vertical line. Okay, it may be a V that's over here, or it may be a V that's up here, or something like that. So you have to find where the V is. And once you find the V, then you go from there. Moving down. Have you ever heard the word quadratic before? Okay. The quadratic function is something that has a squared term in it. So, a quadratic function is kind of like a function that you would get if you took a necklace and you held it at each endpoint and it made it a U shape. Okay? And that U shape, if you imagine that necklace, would be the shape of a quadratic function. It has a funny name, and it's called that, which is pronounced how? Parabola. Okay? Or if you want to say it funny, just say parabola. The most famous parabola in the United States that you may not know of is named the Golden Gate Bridge. The Golden Gate Bridge in California is actually a parabola. The shape of the cables are hanging from two huge towers, and they hang in the shape of a parabola. Now, has anybody been in the physics class and watched the bridge illustration yet? There's a bridge in Tacoma that's no longer there that also was hung in the shape of a parabola, but it didn't have the right structural support, and due to the tides and the winds, it started to have a rhythmic motion, and it actually ended up flipping, in like rotating and flipping, because it wasn't built properly. So if you're interested in parabolas and those kind of things, that's a degree called civil engineering. And it's a whole field where they design roads and civil structures and stuff like that. So it's a huge area where math is used down the road in a more advanced way. So this is the very tip of the beginning of that idea. Anyway, let's take a look at what a parabola looks like in terms of a function. Start with the number 0, 1, and 2. Easiest numbers to always start with. So 0 squared minus 3, 1 squared minus 3, 2 squared minus 3. Think with me here, John. What's 0 squared minus 3?
0,
Good. Okay. So that's 0, negative 3. How about 1 squared minus 3? Felipe? 1 squared minus 3. If you haven't done these, do them on your paper right now. Negative 2. Good. So that's the point 1, negative 2. And 2 squared minus 3, Nate? 1. So that's the point 2, comma 1. So plot those 3 points. 0, negative 3, 1, negative 2, and 2, comma 1. What do you notice instantly? Are they in the shape of a line? No. Can you see the curve? Part of the curve? What part of the curve do we have? Only how much of it? Only half. How do we get the other half of the curve? All right, so what point do I need to plug in? Let's plug in negative 1. Now, on your calculators, remember, if you were to plug this in, you need to put your parentheses around the value of x, because what is negative 1 squared? 1. Minus 3 is negative 2. So be careful if you use your calculators here to put in parentheses when you evaluate. So we have the point negative 1, negative 2. So plot that. And what do you notice about that red point versus the blue point flipping across? What are they to each other, do you see? Symmetrical, aren't they? They're symmetrical to each other. Let's make a guess. Do you think there's going to be a point symmetrical to this one up here? Okay, right about there. Let's check. Let's plug in negative 2. Negative 2 squared minus 3. What's negative 2 times negative 2? 4 minus 3, 1. So sure enough, it is symmetrical. Change the x into a dot. And now you have to draw your parabola. Now here's, on a parabola, you got to be careful here, Noah. At the bottom, don't make it a V. Think of the chain. Does the chain go down and make a V, or does it? What does it do at the bottom? It's a curve. So make a gentle curve at the bottom, and make sure you extend your parabola all the way up to the top. And then put arrows at the top. Okay, so it's going to look something like that. So it's curving and it's going up. You have to have arrows on it because obviously there's more off the graph than there is on the graph. But that's the shape of our parabola. Now based on this minus 3 or plus 3 or minus 6 or plus 7 or whatever, this parabola is going to move. And up here on the absolute value, based on if it's a number inside the absolute value or it's a number outside the absolute value, that's going to move as well. Okay? So here we have assignment down at the bottom. So let's start working on that.